I got a problem here. Because what I have is this block, and it's got a nail, and I want to get that nail out. But I'm not strong enough to pull that nail out. So what I need is some way of getting a bigger force on that nail. Okay, fortunately, I have a claw hammer because of this thing here. And I could theoretically do this and pull. But it's the same force. Whatever force my hand was pulling with, that's what the hammer was pulling with. So that doesn't work. So fortunately, there's a way of prying it off. Okay, so if I put the base of the hammer here, see how it's touching the wood there? And if I pull with this, it's a little better, but it's not very good. And I hope you see what I'm doing wrong, because anybody that's ever used a hammer knows what I'm doing wrong. Instead of gripping it in here and trying to twist it, look what happens if I just grip it there. It comes right out. Okay? And that's because of a concept called torque. Okay? And torque has to do with applying a force some distance from a point of rotation. Okay, so the point of rotation, it was rotating around this. In fact, the point of rotation changed a little bit as I rocked the hammer. But we're going to pretend that the point of rotation was right here. And so the torque comes from an expression called R cross F. In AP Physics 1, that cross we don't really deal with. But what that means is R, the distance, in fact, the vector from the point of rotation to where the force is applied. And my force was in this direction. R times this force times the sine of the angle in between them. The sine. Remember when we did work, it was F delta X cosine of theta. That was the dot product. The cross product has to do with the sine. It's a little more complicated because you have to use the right-hand rule if you're doing something like AP Physics C or beyond. In AP Physics 1, we're not going to deal with the actual direction of the torque vector. We're simply going to say the magnitude, the size of the torque, is R from the point of rotation to where the force is applied, times the force, times the sine of the angle in between. That will give the size of the torque, okay? The direction of the torque for AP1, it's okay to say clockwise, counterclockwise, okay? So this one would be, and going the way you're looking, this would be counterclockwise. To me, it's clockwise. Counterclockwise. And we tend to count counter or anti-clockwise as positive. You can define it any way you want. You draw like a little circle in that direction with an arrow and put a plus next to that. If you wanted clockwise to be that, you want to draw it in the other direction. If you define that direction, you're in great shape. Okay? Now, there was something I said I didn't want to pull here, because R times this force times the sine of the angle in between would be much smaller than this R times this force times the sine of the angle in between. The only thing I changed, I didn't change the force, right? I just changed the R. I didn't change the angle. The first time I was pulling like this, so my force was in that direction, perpendicular. Sine of 90 is 1, right? So it ended up just being RF. Here, much bigger R times F times the sine of 90, which is 1. Now, if I pushed like this direction, like this, I wouldn't get very much torque. The closer you get to perpendicular, the more torque you get. The closer you get to parallel, here's R, and here's F, the less torque you get. I'd still have force, still be pulling on the hammer, but I wouldn't get the torque that I want. And torque is really just, you can think of it as a force to make things rotate, a rotational force. Now look, if I push like this, R, F, sine of 180, 0, right? RF, sine of 180, 0. There's nothing that's going to make it turn. If I do this, wow, I could do that all day. I'm not applying a torque, right? Same thing, you close a door. Here's the door, right? You push on the door. If this is the hinge right here, you apply a force. You don't apply a force like this. You don't apply a force like this or like this. You apply a force like this. You are maximizing the torque, because first of all, you don't push right near the hinge, you push at the far side of the door, right? And you don't push at a different angle, you push perpendicular. So torque is all these forces that make things rotate, cause things to rotate. And when I say that, I got to be a little careful, because it really is things that cause a change in the state of rotation. And we're going to look at that. So they change the omega. They cause an angular acceleration.